Hi, welcome to this lesson on calculus, the second derivative. Let's have a look at question 3. We're given f prime of x is equal to 2x squared minus 8x. So we are already given the first derivative, so pay careful attention to that. We're not given the original function. If we want to classify any stationary points and intervals where the original function f is increasing or decreasing, and then we want to classify any intervals of concavity and if there's an inflection point. Okay, so we can jump straight in because the stationary points and the intervals of increasing or decreasing rely on the first derivative. So that's f prime x, which is 2x squared minus 8x. If I set that equals to 0, I get my stationary points. Okay, so I can factor out a 2x, and I'm left with x minus 4. Okay, so if I expand that out, I get back that expression, equals to 0. So by the zero property of algebra for factors, we can set each factor equals to 0 now. All right, and then doing so, we get the following two solutions. For the first one, we'll get x equals 0, or the second one, we'll get x equals 4. Okay, so those will be the stationary points, but because we weren't given the original function f, we can't say what the y values will be. But we can also just sort of figure out that because this is a square term of the derivative, when we go one power up to the original function, it's most likely going to be a cubic function. Okay. What about when the graph increases? So the intervals of increasing is when the first derivative is greater than 0. So that implies 2x squared minus 8x greater than 0. So we're solving a polynomial inequality, so we need to follow the steps, fully factorize it, which we've done. Okay, put our critical values on a number line. So the critical values are the stationary points, x is 0 or x is 4. So let's go ahead and do that. Then we test the regions. So if I take 5, 2 5s are 10, 5 minus 4 is 1, so it's going to be a positive number. Then if I take a number between here, let's say 1, I'll get 2 times 1 is 2, and then 1 minus 4 is negative 3, so when I multiply it, I get a negative output. And then if I take, let's say, negative 1 here, then it's going to be negative 2 times negative 5, which is a positive output. So intervals of increasing is when it's positive on the number line. So that means x is an element of negative infinity up to the turning stationary points. Here it's 0 and 4. So up to 0. And then it takes a break and then joins up again at 4 to infinity. All right, now that we've done all that hard work, we can look at the intervals of decreasing. That's when your first derivative is less than 0. So on that number line, we're looking for the negative sign here. So therefore, the x is an element from 0 to 4. Okay, so that is the intervals of increasing and decreasing and the stationary points. What about the concave up and concave down? So let's have a look at concave down first. We want the second derivative to be less than 0. Okay, so the first derivative is 2x squared minus 8x. So the second derivative is taking the derivative of that derivative. So it's going to be 4x minus 8, less than 0. So I can take the 8 across, so I get 4x is less than positive 8. Dividing both sides by positive 4, I get x is less than 2, where x is a real number. So in interval notation, that is x is an element from negative infinity to positive 2. That the graph will have the concave down shape, so it'll be below its tangent lines. Okay, what about concave up? Okay, so for concave up, it's the second derivative greater than 0. So that implies, again, 4x minus 8 is greater than 0. So we apply the same logic to this linear inequality. So 4x is greater than 8. Dividing both sides by 4, x is greater than 2. Okay, so in interval notation, that's x is an element from 2 to infinity. And then lastly, for the inflection points, if there is an inflection point, we set the second derivative equals to 0. Okay, and that implies 4x minus 8 equals 0. Then solving this equation, we get x equals 2. So is that a point of inflection? Well, I would say so, because it goes from concave down less than 2, and then it goes concave up, which is greater than 2 at that point. So at the point 2, it changes concavity. So I would classify x equals 2 as an inflection point of this graph. Okay, so that's how we would do this type of question. I'll see you in the next one.